Toroidal Propeller. Introducing the innovative Toroidal Propeller, a marvel with blades shaped like a torus, akin to a donut. Beyond its unique appearance, these blades demonstrate remarkable efficiency, doubling the propeller's performance on boats, leading to enhanced speed and fuel economy. Additionally, this revolutionary design significantly reduces noise levels in both drones and boats. In this video, we'll explore the mechanics behind its efficiency and showcase real-life examples of its application. Although the physical dissimilarities between the toroidal prop and a standard prop are readily apparent, the substantial benefits they offer might not be immediately evident. Upon closer observation of their side-by-side operation, the distinctions become clearer. Notably, the toroidal prop generates significantly fewer bubbles, known as cavitation, at the blade tips despite sharing the same size and rotational speed as the standard prop. This reduction can be attributed to the toroidal prop's ability to generate fewer trip vortices, which minimizes noise vibrations and enhances efficiency. It is believed that the toroidal prop spreads vortices across the entire blade, diverting their concentration away from the tips. In another compelling comparison, we observe that the toroidal prop pulls in more surrounding fluid as it spins, drawing dye from a greater distance into the blade. This phenomenon further boosts efficiency and thrust, solidifying its position as a revolutionary propeller design. Aerodynamic Noise. Addressing the challenge of aerodynamic noise while maintaining peak performance is crucial. Standard propellers, found not only in drones and planes but also boats, produce this noisy disturbance due to vortices generated by their fast-moving tips. The propeller's rapid rotation, sometimes nearing the speed of sound, leads to minor airflow imperfections and results in a loud sound profile, as demonstrated in tests. Prolonged exposure to such noise can lead to noise-induced hearing loss. Enter the toroidal propeller, the solution to this issue. By utilizing torus-shaped blades, this innovative design effectively mitigates the annoying noise typically associated with traditional propellers, which tends to fall within the 1 to 5 kHz range, where our ears are most sensitive and alert to loud sounds. Two main toroidal propellers. There are two primary types of toroidal propellers that easily catches attention. One developed by Sharrow, primarily for marine applications, and the other by a research group at MIT's Lincoln Laboratories, specifically aimed at creating exceptionally quiet drones. The initial concept of employing the toroidal or annular wing shape to achieve a quieter propeller stemmed from our own brainstorming. To explore this idea further, one of my interns took charge, generating multiple iterations with varying shapes to test and determine which configurations yielded the best results. Toroidal propeller structure. The structure of a toroidal propeller revolves around the creation of a vortex ring, a circular airflow encircling the propeller blade. This vortex forms a low-pressure zone drawing air through the center of the toroid. Due to the toroidal blades' slower rotational speed, they produce significantly less noise than conventional propellers, making them an attractive option for aircraft operating in noise-sensitive areas. The unique shape of the toroidal propeller's two blades loops them back together, creating a close-form structure. This design minimizes drag effects caused by blade tips by dispersing vortices throughout the entire edge of the blade, while also enhancing the propeller's stiffness. Sharrow Blades. When comparing the propellers from MIT and Sharrow, a notable distinction lies in the Sharrow Blades' more aggressive pitch and the smaller, less conspicuous holes on them, catering to their specific uses in air and water. To demonstrate the remarkable noise reduction achieved by these toroidal propellers, let's listen to a boat equipped with both a standard and toroidal propeller. The difference in noise output is astonishing, a trend also observed in drone applications as illustrated by the graphs displaying the significant noise reduction in key frequency zones achieved by the toroidal propeller compared to the standard one. Moreover, in real-world scenarios, a boat with a motor running at 4,000 RPM experiences a staggering 205% increase in efficiency when equipped with a toroidal propeller compared to a standard propeller. The toroidal propeller also reaches maximum efficiency much earlier, particularly advantageous as boats often cruise in the mid-range. Collectively, these features lead to extraordinary average fuel savings of approximately 20%, offering invaluable benefits of faster, quieter, and more fuel-efficient vessels. These advantages hold immense significance as they can reduce sailing time, lower fuel consumption and emissions, and mitigate noise pollution's adverse effects on marine life, which poses an increasing threat to their communication and navigation. Particularly crucial for large cargo ships, the backbone of global trade, traveling vast distances across oceans to transport goods ranging from electronics to food and raw materials. Additionally, the toroidal propeller enhances handling and reverse thrust in boat operations while enabling more efficient drone flight, opening up new possibilities for air travel and reducing disturbances to both people and nearby animals. Urban air mobility. Urban air mobility, UAM, is a rapidly emerging industry seeking to revolutionize on-demand air transportation in urban areas, but the prevalent issue of noise pollution poses a significant obstacle to its widespread adoption. In this context, toroidal propellers present a promising solution, potentially transforming UAM into a more sustainable and viable mode of transport. Bluebird Aerosystems, a leading company in this field, actively explores collaborations with UAM firms and other potential clients to introduce their innovative toroidal propellers to the market. Beyond UAM, these quiet propellers hold potential for diverse aviation applications, including commercial airliners and military aircraft, where their noise reduction benefits can enhance passenger comfort while mitigating the environmental impact of air travel. Moreover, they offer an appealing alternative for industrial and infrastructure inspections as well as agriculture monitoring, broadening their scope and impact across various sectors. Drawbacks. While the toroidal propeller offers numerous advantages, it also comes with certain drawbacks worth considering. One significant limitation lies in its manufacturing complexity, resulting in higher production costs compared to traditional propellers. Presently, toroidal props are manufactured using CNC machines or 3D printing, rendering them approximately $5,000 each, whereas standard ones cost around $500. However, the increased efficiency of the boat equipped with toroidal propellers may eventually offset this initial expense, making it cost-effective over time. Furthermore, with rising popularity and mass manufacturing, economies of scale could lead to cost reduction in the future. Another area of uncertainty pertains to the scalability of toroidal propellers for larger ships or aircraft, which typically operate at slower motor speeds. Despite this, potential benefits from such adaptations remain promising. Excitingly, the current applications are merely scratching the surface, and many unforeseen possibilities may emerge, ranging from highly efficient hydro generators to whisper-quiet computer fans, further expanding the toroidal propeller's potential impact. Challenges. Despite the numerous advantages of toroidal propellers, certain challenges must be tackled to establish them as a prevalent technology in aviation. Among these hurdles is the necessity for extensive research and development to refine the design and enhance the performance of toroidal blades. Additionally, regulatory obstacles may surface since toroidal propellers represent a relatively new technology, potentially mandating certification from aviation authorities to ensure their safe and compliant usage. Addressing these challenges would be crucial in unlocking the full potential of toroidal propellers and fostering their integration into mainstream aviation. Conclusion. The toroidal propeller represents a revolutionary breakthrough in transportation, offering enhanced efficiency, reduced noise levels, and the potential for widespread adoption in various industries. Despite challenges in manufacturing and regulation, ongoing research and development promise to unlock its full potential, shaping a more sustainable and quieter future for aviation and beyond. Thank you for watching. Stay safe and stay tuned for more exciting content on Tech Brilliance TV.